Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA 2021, Paper 3, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. Solve 4 plus x equals 12. Circle your answer. Okay, so this is a linear equation that we need to solve. And in order to solve it, we need to get x by itself, don't we? So if I've got 4 plus x is equal to 12, then I can isolate x by subtracting 4 from both sides then, can't I? That will cancel with that, leaving you with just x on the left and 12 take away 4 gives me 8 on the right. So that's my answer there. X is 8. Question 2. Circle the largest number. When you're comparing decimals, you need to start from the digit with the highest value, don't you? So in this case, the highest value of each of these digits is the units digit. They're all 4, so they're all the same. So we can't use those to discern which one is the largest. So let's go along to the next digit. This one is a 5, this one is a 5, this one is a 5, and this one is a 5. So they're all the same. Let's go along to the next digit. This one is a 0. This one, it's not showing. I'm just going to add a 0 in there because that must be 4.50 then, isn't it, if it's 4.5. So that one is 0, that one is 1, and that one is 6. Okay, so I can see then that this one is the biggest, because 6 is bigger than 1, which is bigger than 0, which is bigger than 0. Question 3. Circle the expression that means half the value of x. Well, half the value means take the value of x and divide it by 2, and isn't it? And multiplying by half is the same as dividing by 2. So it's this one here, x over 2. X over 2 is equal to half the value of x. Question 4. Circle the value of 10 to the power of 6. 10 to the power of 6 is a 1 followed by 6 zeros. Okay, which is a million, isn't it? It's that one there. It's 1 million. Question 5. Complete the bank statement. So we've got this this grid here. The first column is dates. That's all complete. Descriptions is all complete. Then I've got credit, debit, and balance, which has got some blanks in it that we're going to have to go and find. Okay. Right. So I think the grayed out ones we don't need to do. It's just the white boxes that we need to find. Okay. So we're not going to have to do this one, this one, this one, or these. It's just the white boxes that need to be filled in that don't have anything in them. Okay. Right. So what does credit and debit means? Credit means money going into the bank. So when you have a credit, that adds to your bank balance. A debit is when you take money out of your bank, so that is going to be subtracted from your balance. Okay, so if the starting balance was 670.43 and I have my salary going in, which is a credit, that's an addition to my bank balance, isn't it? So that is going to be added on to the balance for the new balance. So my new balance is going to be the old balance plus the credit of 2,156.75. So reaching for the calculator, 670.43 plus the salary of £2,156.75. That comes to £2,827.18. Okay, so feeling pretty flush at this point, but now all the bills start going out. Water bill goes out, that's a debit, isn't it? So that's money coming out of the account, so I need to subtract £48.97 from the balance. So the balance minus £48.97, that's going to reduce the balance to £2,778.21. 2778.21. Okay, and then finally I can see that the mortgage payment goes out. Now I don't know what the debit was, but I do know that the new balance is £1,642.49. Now I can find out how much went out by subtracting that new balance from the old balance then, and that will tell me how much has disappeared out of the account. So I'm going to subtract 1,642.49 from my previous answer, and that tells me £1,135.72 must have been deducted, so that is the value that goes in there then. So this is going to be 1,135.72. Okay, that's the mortgage payment. Question 6, put the numbers 1, 2, 3, 4 and 6 into the circles so that each line of the three numbers multiplies to 12, and the total of the vertical line is one more than the total of the horizontal line. Use each number once. Okay, now this is going to be a massive trial and improvement thing going on here. Right, so I'm just going to play around with these numbers to see what I can do. So I've got 1, 2, 3, 4 and 6. Now my first thought that it was probably the 3 that went in the middle there, but I'm thinking that isn't going to be right actually. I'm throwing that idea away in the bin. I think instead I'm looking at what can I pair up numbers that are going to multiply to give me the same number, and then there's going to be one number left over that I'm going to put in the middle then. I think that's my new plan. And looking at through those numbers, I can see like 2 times 6 makes 12, and 3 times 4 makes 12, and 1 is the one left over. So if I put 1 in the middle, and then I put like the 2 and the 6 somewhere, and the 3 and the 4 somewhere, then hopefully that works. Does it? So then each of the 3 lines will multiply to give you 12. That is true. And the total of the vertical line is one more than the total of the horizontal line. So what does 1 plus 2 plus 6 add up to? That adds up to 9. And 1 plus 3 plus 4 would add up to 8. So the total of the vertical line is 1 more than the total of the horizontal line. Okay, so the bigger one, the 1 and the 2 and the 6 are going to have to be the vertical line, and then the horizontal line is 1 less. It's there, it's those 3. Okay, so 1 goes in the middle, already got that, and then the 2 and the 6 are going to go in the vertical line, and the 3 and 4 are going to be in the horizontal line. So 2 times 1 times 6 multiplies to 12, 3 times 1 times 4 multiplies to 12, 2, 1 and 6 adds up to 9, 3, 1 and 4 adds up to 8, which is 1 less. Okay, so I think it meets all the criteria. I'm done. Okay, so it's just a matter, you have to, with some of these ones you just have to get stuck in and play around and see if you can make it work. We did. Let's move on. Question 7. Point A is 217 meters above sea level. Point B is 145 meters lower than point A, and point C is 59 meters below sea level. And point C is 59 meters below sea level. How much higher is point B than point C? And it looks like we've been given a handy chart down here to plot our points on, because it's got sea level in the middle and an axis along the side. So I'm going to use that to help work out where the points go. Okay, so sea level, let's make sea level equal to 0. Then point A is 217 meters above sea level. So if I go up on my scale, 217 units, then I'm going to find A there, aren't I? Okay, at 217 units above sea level. B is 145 meters lower than point A. Okay, so what is 217 take away 145? That's 72. So I'm just going to write that down. 217 minus 145 equals 72. Now you really need to get into the habit, like I've done. It's just if you type anything into your calculator, write it somewhere on the paper, because often there are credits for the steps in your calculation. Yeah, so just make sure you're writing stuff down. If you type it in the calculator, write it on the sheet. So B, so I've got 217 minus 145, and that comes out to be 72. So that means B has got to be at a height of 72 meters above sea level. Okay, so that's B. That's going to be at 72 meters above sea level. And then I've got point C, which is 59 meters below sea level. So C is going to be down here then, isn't it? And that is at minus 59. Okay, so negative is below sea level and positive is above sea level. Okay, so how much higher is point B than point C? Then the distance from here to here, look, that is going to be this distance, like this negative bit, which is 59, plus this bit here, the distance from 0 to 72. Okay, so it's going to be that 72 as well. So distance between B and C then is equal to 72 plus 59, and that is equal to plus 59, that comes to 131. Okay, in meters. So how much higher is point B than point C? It's 131 meters higher. Question 8. Here are 4 number cards. We've got 2, 5, 6, and 8. Use each card once to make this calculation correct. Something plus something minus something equals 1. Okay. So my 2 numbers added together then is going to be 1 more than my 2 take-away numbers from each other, if you think about it. So I want to pick my numbers so that the 2 that I add together are going to be worth 1 more than the 2 I take away. So what have I got? I've got like 2 and 8 and 5 and 6. So again, I'm going to pair up the small one with the big one and the 2 ones in the middle, because they're gonna have a difference, aren't they? And if you think about it, 2 plus 8 is equal to 10, and 5 plus 6 is equal to 11. So if I start by adding the 5 and the 6 together, that's going to give me 11 then, isn't it? Okay, so 5 plus 6 is 11, and then if I take away the 2 and the 8, that's going to take me down to 1, isn't it? So 11 take away 2 is 9, take away 8 is 1. Okay, so that seems to work. Question 8b, list all of the possible pairs of cards. 2 have been done for you. Right, I'm just going to quickly write down my numbers again. 2, 5, 6, and 8, so don't forget. Okay, so they're the cards. Now, actually, I'm a bit annoyed that they've done some, because I like to be systematic about ranking my cards. And the fact that they've done 2 for me in an order that I wouldn't normally do it in is a little bit annoying. So what I would normally suggest you do is that you keep 1 the same. So you do like 2 and then 5, like they've done. There's no problem with that. But then I would keep 2 the same, and I would go to the next one, 2 to the 6, 2 and 6, and then I would do the next one, 2, 8, and then I would switch to the 5 after that, and I'd do 5, 2, 5, 6, 5, 8, like that, and run through them with all the 5s at the beginning. That way, if you're systematic, you're less likely to miss one out. So that's why I'm a bit annoyed they've actually done one already for me. So they've done that one already, haven't they? And they've done that one already. So I'm just going to have to grit my teeth and just pretend that didn't happen then, and yeah. So, and miss that one out. So I'm going to miss that one out when I write it down. So and otherwise be systematic. So I'm doing 2 and 6 and 2 and 8. And then I'm going to switch to 5. But I'm not going to do 5 and 2 because that's already been done. So I'm going to do 5 and 6 and then 5 and 8. And then I'm going to switch to the 6 and I'm going to do 6 and 2 and 6 and 5 and 6 and 8. And then I'm going to do 8 and 2 and then 8 and 5 and then 8 and 6. Okay? So altogether I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different combinations there. Okay, that looks about right to me. Yeah, thanks, no thanks for putting the numbers in for me, examiner. Question 8c, write down the probability that the first card is an even number. Now, probability is equal to, so the probability first card even, probability is defined to be successful outcomes divided by total outcomes. Now we saw from the table earlier there are 12 distinct outcomes, aren't they? I went through and counted them a minute ago. So that goes on the bottom, that's my total outcomes. Now the number goes on the top is the successful outcomes, and by success, success means basically this condition happens, that the first card is even. So if we go through and look which outcomes have the first card even, that one does, that one does, and that one does. All the numbers beginning with 2, all the pairs beginning with 2, and the ones beginning with 6, and the ones beginning with 8. They are all even numbers to start with. Okay, so you can see that's 9 of the 12 solutions then, isn't it? Okay, so the probability then of picking a combination where the first card is even is going to be 9 out of 12. Okay. Question 9. School A has 72 tutor groups. Each group has 28 students. School B has 16 tutor groups. Each group has 18 students. Show that the number of students at school A divided by the number of students at school B is a whole number. Okay. So we just need to work out the total students for school, don't we? So for each school. So total for A, that's going to be my 72 groups multiplied by the 28 students in each group. So 72 times 28, that comes to 2016. So there's 2016 students in school A. Does that seem reasonable? It's a big school, but it's not beyond the realms of possibility. And school B then has 16 tutor groups and each has 18 students. So 16 times 18, that is equal to 16 times 18, 288. So that's a much smaller school. 288 again, very small but possible. So show that number of students in school A divided by number of students in school B is a whole number. So what is 2016 divided by 288? Just a job for tapping into the calculator there. So 2016 divided by answer, that comes out to be 7. So I've done it, haven't I? I found the totals for A and B. I divided one by the other, and it's a 7, which is a whole number. Question 10. Boxes of chocolates each contain 25 chocolates. One box costs £3.25. A shop has a special offer. It says 2 boxes for £5. How much cheaper per chocolate is the special offer? So I think we're going to work out what the normal rate per sweet is, and then the discounted rate, and then we can take away one from the other, can't we? So boxes of chocolates each contain 25 chocolates. So one box costs £3.25 at the normal rate. So each choc costs, it's going to be the £3.25 divided by the 25 chocolates in the box. That gives me 3.25 divided by 25. That comes out to be 0.13. That's about 13p per for chocolate then, isn't it? So that's 0.13 or 13 pence. And then the discounted rate, if it's £5 for 2 boxes, then each chocolate costs, well, I've spent £5, haven't I? But I haven't got 25 chocolates this time. I've got 2 lots of 25, which is 50, isn't it? So I've got £5 divided by 50, which is 0.1 or 10 pence per choc. So that is 0.10 pence per choc. Okay, so how much cheaper per choc is the special offer? So each choc is 0.13 minus 0.10 equals 0.03 pence cheaper. Okay, bargain. Question 11. In a game, the player going first uses crosses and the player going second uses circles. To win the game, a player must get 3 crosses or 3 circles together in a line. The line must be horizontal, vertical, or diagonal. Here is the position in a game. It's Amy's turn to put a cross on the grid. She wins if she puts a cross in B3. Yes, she does. Write down all the other squares where she could put a cross to win the game. Okay. Right, so she could put one here, like in B3, to win the game. Okay. But where else could she put one? She could also put one here. So that would give me a line of 3 there. Look. So that's in B2. Where else? B3 we've already talked about. We could put one at the other end. We could put one here at E3. That would work. Okay. So then I'd get like 3 that way. Where else? I could put one here at D5. That would give me 3 there. I could put one there at C5. That would give me 3 in a line that way. Any other possibilities? I think that's all of them, you know. Anyway, she's got 5 winning moves. That's pretty much, isn't it? She only needs 1 to win. We found 5 of them, so that's good. Well, 4 others than the one she'd already found anyway. Yes, so I found 4 more. Part B, it says Amy goes first in the next game. Assume that she will choose a square at random. Write down the probability that she will put her first cross in square F6. Okay, so the probability then that she picks F6 is, well, it's that one square there. So there's 1 outcome. So there's 1 successful outcome. We talked about probability being successful outcomes over total outcomes. So there's only 1 winning. There's only 1 place you can put it, which is there. And how many places she got to pick from? Well, this grid is 6 by 6, isn't it? And 6 times 6 is 36. So that means there are 36 possible squares she could have picked. So the probability of her picking F6 is 1 chance in 36 outcomes, isn't it? Okay, so 1 over 36. Part C says, in fact, Amy decides to put her first cross into a corner square. What does this mean about the probability that she will put her first cross in F6? Tick a box. It is smaller than the answer to part B. It is greater than the answer to part B. It's the same as the answer to part B. Well, it's actually going to massively increase her chances of putting it in that square, isn't it? Because rather than having 36 different outcomes to pick from, she's only now got 4 different outcomes to pick from because there are only 4 corners of the grid. So her probability now of picking F6 is not 1 out of 36, but 1 out of 4. Now 1 out of 4 is a much bigger fraction than 1 out of 36. If you can imagine, if you take something and divide it up into 36 pieces, they're going to be much smaller than if you take that same thing and divide it only into 4 pieces. So the probability then is going to be greater than our answer to part B. Okay, and that is enough reason there that probability that f6 is a quarter. That's plenty to tell me that it's bigger. Question 12. A dolphin and a whale are drawn to scale. There they are. That doesn't mean that's how big they are. You know, a dolphin isn't that tiny thing, but they are drawn to scale means that relative to each other, if that was the size of the dolphin, then relatively that would be the size of the whale then. Okay, so the actual length of the dolphin is 3 meters. Estimate the actual length of the whale. You must show your working. Okay, and I've got a little bit of a problem here because I'm working on a virtual paper and I've got a virtual ruler which has got no numbers on it, and it's probably different from a real life ruler. But anyway, so I'm just gonna look and see how big that dolphin is compared to the whale using my measurement. Now, if on yours you'd probably do the same thing, but you're probably going to get different numbers to me. See, I make that like 12 divisions from nose to tail, so it's 12 of my magical virtual units on my ruler in here. Now if I compare that to the whale, he is 10, 20, 30, 40, 50. He's 50 magical virtual units along this scale, isn't he? So he's 50. Oops. So from nose to tip, nose to tail, he is 50 magical made up units of my virtual ruler. Okay, so but from that I can kind of work out an estimate of how much bigger a real whale is compared, and it doesn't matter. You should get a similar answer even if you use different units because it's going to be relative. Okay, so what I'm going to do is I'm going to take my dolphin, so the whale estimate is going to be my 3 meters that I know that the dolphin is. I'm going to divide that by the number of units that I measured for the dolphin, which was 12, and I'm going to times that by the number of units I measured for the whale. Now, if you use a real ruler and a real exam paper, you just do the same thing. So you measure with your thing that number, and it should come out to be fairly similar to what I come out with because it's the relative size that we're talking about here. So don't believe me, try it. So 3 divided by 12 times 50, that comes out to be 12.5. So my estimate is that it's going to be 12.5 meters. Question 13, work out the area of this triangle. Okay, so I've got 9.8 centimeters tall and 2.6 centimeters wide. Now I know the formula for area of a triangle. It's half base height, isn't it? Okay, which is a half times the base. So the base then is this line here, it's 2.6, and my height then is this one here, it's 9.8. Okay, so just tapping that into the calculator, 0.5 times 2.6 times 9.8, that comes out to be 12.74. Okay, what units? If it's centimeters times centimeters, that is centimeters squared, isn't it? Part B says a circle has a radius of 11.5 centimeters. Work out the area of the circle. So my formula for a circle: cherry pie delicious, apple pies are 2. So see, cherry pie delicious, circumference of a circle is pi times its diameter. Apple pies are 2, area equals pi times r squared. Now it's this one we want here, isn't it? We don't want circumference, we want the area, so I'm going to pick that formula. So area equals pi r squared, which is pi times 11.5 squared. Let's type that into my calculator. I need the shift key to press the pi. Can you see it's down there above the times 10 to the x button? So pi times 11.5 squared. I'm just going to hit the square button. That gives me it in terms of pi, and then I'm just going to press symbolic to decimal to get 415. It's going to round off to one decimal place, 415.5. Okay, I could just round off to the nearest unit. 415 would be fine as well. You could write down all the units if you want to, but that would take time. I'm happy with that. It's going to be in centimeters squared. Question 14. A machine takes 4 seconds to fill a packet of crisps. In total, how many packets can 35 of these machines fill in 8 hours? Now, first off, we've got different units here, haven't I? I've got 4 seconds here and I've got 8 hours here. So in order to work out this problem, I'm going to convert one into the other. Now, if I convert seconds into hours, it's going to be a horribly small decimal. So I'm going to convert the hours into seconds instead. I'm going to say that is equal to, there are 60 minutes in an hour, and there are 60 seconds in a minute. So that's going to be 8 times 60 times 60, isn't it? That's 28,800 seconds in 8 hours. Okay? Right, so it takes 4 seconds to fill up a packet of crisps. So one machine how many could that fill up? It's going to be the 28,800 seconds available divided by 4, because it takes 4 seconds to fill up one packet. So divide that by 4, I'm going to get 7,200. So that means that each machine can pack 7,200 packets in the 8-hour period then, isn't it? Okay, so but we've got 35 machines. So all the machines is going to be, each machine can pack 7,200, and I got 35 of them. So how many packets of crisps is that altogether? That's going to be loads. That's a quarter of a million. So 252,000 packets. That's a lot of crisps. Part B says each packet of crisps contains 32.5 grams of crisps. At what rate does the machine put crisps into the packet? Give your answers in grams per second. So we're looking again at a machine, one machine, and not 35 machines. So just bear that in mind. And we know that a machine can pack a packet of crisps in 4 seconds. So one machine takes it takes 4 seconds to pack one packet. So then the ratio of 32.5 grams then. So we can pack 32.5 grams in 4 seconds. So the rate is going to be that 32.5 grams divided by the 4 seconds it takes to pack it. Okay, so that means that 32.5 divided by 4 gives us 8.125. 8.125. So this the machine packs 8.125 grams per second. Okay, so we've given our answer in grams per second, 8.125 grams per second. Question 15a, complete the table of values for y equals x squared minus 2. Okay, right, now if you don't have a Casio calculator, you can just work these out one after the other. So what you're going to do is you're going to take each value of x, you're going to sub it into the equation. So y equals the first value minus 3 all squared minus 2, and work that out. So minus 3 squared is 9, take away 2 is 7, so I know that 7 goes there. Okay, but if you've got one of the Casio calculators, it's got a kind of a handy tool built into it for doing this sort of thing. just go and press the menu button on your calculator, and you want to go to the table mode, okay, and select that. Now that's going to tell you f of x is equal to, and that is where you're going to type in this bit here. So f of x is equivalent to y, and we're going to type in that bit after the equals sign into the calculator. Now I need an x, and you can see that it's there above the right bracket in red. So in order to access that, I'm going to press the alpha key and then that key, and it's going to come up x. Okay, then I'm just going to hit the square key to get x squared, and then minus 2 to finish it off. Okay, now pressing equals, it's going to say g of x is equal to, I'm not going to put a second function in, so I'm just going to press equals again. And then it's going to say start, end, and step. Now the start value is the lowest value on my table. That's going to be -3, -3. Press equals, and then the end value is going to be the last value on my table. That's 3. Press equals again, and the step is what the table is going up in. You can see that the table is going up in ones, so the step is just 1. So I'm just going to press equal again because it's assumed it's going to be 1. And you can see then I get a table. It's transposed the other way, so my table is going down rather than across. But you can see that the first value is -3, and that goes with 7, which matches the calculation I did earlier. The next one, -2, goes with 2. That matches what was already on the table, as does -1, -1. And then you can see 0 goes with -2, which also matches. 1 goes with -1, that also matches. And 2 goes with 2. So I need to fill that one in. That one is 2 there. And then finally go down a bit more, and I can see that 3 goes with 7. Okay. That's it. That's all my values. Okay, so part B, we need to now draw those points or plot the graph. So we're just going to use each one of these as a coordinate. So my first coordinate is -3, 7. So going along to -3 and up 7, that means my first coordinate is there. -2 goes with 2, which is there. -1 goes with -1, there. 0 goes with -2. 1 goes with -1. 2 goes with 2, and 3 goes with 7. Okay, now this curve y equals x squared minus 2 is a quadratic curve, isn't it? So I was expecting the curve to look like a parabola. I was expecting it to look like this with the line of symmetry down the middle. Is that what I've got? Yeah, I do, haven't I? Because like that line of symmetry is running down the y-axis actually, so it's reflected in the y-axis if you think about it. And it's got that shape that I'm looking for, so I'm pretty sure I've worked out the values and plotted them correctly. Okay, now if you're looking at your points and you're not seeing a parabola like you expect, then you've probably made a mistake. Okay, but mine is looking good, so I'm going to go ahead and join them up. Now, so you need to join them up in a nice smooth curve passing through the center of each of your points that you've drawn. Now a little bit of wobble is not important, but you do want to go through each point, and you don't want to feather or like put multiple lines on. Okay, I'm reasonably happy with that. It looks fairly symmetrical. You can see it's got a fair bit of wobble in it, but you know, it doesn't have to be perfect. It just needs to be a smooth continuous curve going through each of your points. Okay, I'm not Leonardo da Vinci. I don't need to be able to draw a perfect curve in order to get the marks. Okay, but like I say, what you want to avoid doing is missing the points or doing multiple lines. That will get you marked down. Question 16a. Towns A and B are shown on a centimetre grid. What does the shaded area represent? Does it represent all the points nearer to A than to B, all the points at least 30 miles from B, all the points halfway between A and B, all the points within 20 miles of A? Okay, well, I can tell you it's that last one. All the points nearer to A than to B, that would be the perpendicular bisector of the 2 points. So if you constructed the bisector that cut this exactly in half, then all of these would be closer to A than to B. So that's the first one. The second one, all the points are at least 30 miles from B. That would be a circle centered on B. So if I was to draw a circle centered on B, radius 3, because it was 30 miles, like a circle like that, then everything outside the circle would be what I was looking for that second option. It's definitely not that, is it? The third option, all the points halfway between A and B. Again, that would be the perpendicular bisector. It would be that line there that cut this line exactly in half that I talked earlier about, but this time it would just be the points on the line. Okay, it's none of those. It's all the points within 20 miles of A. All the points on the circle are exactly 20 miles from A, so all the points inside the circle are 20 miles or less from A. Okay, so it's definitely that last one. 16b, complete an accurate drawing of triangle PQR. So the angle QPR is 53 degrees and the length of side PR is 7.5 centimeters. Okay, so we're going to need some kit for this. You're going to need your protractor, a pencil and a ruler. And I always suggest we're going to start off by drawing a little sketch. So I'm going to draw a triangle PQR in the top here. Now I know the bottom is P and Q, and I've asked to draw the angle QPR, so QPR is at the top, isn't it? So that we're talking about this angle down here on the left. So that's 53, and the length of side PR is 7.5, that's this side here, isn't it? Okay, so if I draw a little sketch first, it just helps work out where I need to construct my real thing so I can get it right the first time. Okay, so we're going to place the protractor at the angle P. Now make sure the center of the protractor is exactly on the center of P and the bottom line of the protractor lies along the line of your angle. Okay, so once you've got it, and just take a bit of time to get it right. Once you've got it aligned, we're going to count up using the scale that starts at 0. So 0, 10, 20, 30, 40, 50, 1, 2, 3. So I'm going to put a little mark there. Once you mark the angle, you can just move the protractor out of the way. And I'm going to use the ruler to join P through that mark that I've made. Now we need to make this line of side 7.5 centimeters. So I'm going to put the ruler so it's at 0 at P, line it through the mark that I made, and then I'm going to draw straight up to 7.5 on the ruler at the top. Okay, so from 0 through my mark up to 7.5. Okay, so that point at the end of my line there, that must be the point R there, mustn't it? So I'm going to mark that at the top, and just to finish off my triangle, I'm going to join point R to point Q with a straight line. Now I'm done now, but I just like to double check these things. So after you've done your construction, just make sure that your sides are length. So that is definitely 7.5. That is definitely 53. Okay. So it only takes 2 seconds to just double check at the end, but you'll just catch some errors if you do. Question 17. Multiply out 5x lots of 3x minus 2. Okay, so we've got a single bracket here. So this term on the outside of the bracket we need to multiply by with both things inside the bracket. So first off, 5x times 3x. Well, 5 times 3 is 15, and x times x is x squared, isn't it? So that gives me 15x squared. And then 5x times negative 2, that's going to be minus, 5 times 2 is 10, minus 10x. That's it. 15x squared minus 10x. Question 18. The scatter diagram shows the age and value of some cars in 2019. All the cars were the same make and model. So we've got value up the one side and the age of the cars in the other direction. So what type of correlation does the scatter graph show? Now you can see from left to right that the graph is generally sloping downwards. So we call that negative correlation. Okay, now the points are all quite close to that line, apart from that one weird one off to the side there. So I'd say it's quite strong, but it isn't asking me to comment on the strength. So I'm just going to stick with negative correlation. Okay. Right, so write down the value of the car that was an outlier. Well, I did mention that kind of weird one down here. It's that one, isn't it? That's the outlier. It's a bit unlike the other ones. Okay, so it's a 3-year-old car and it's worth £4,000. So write down the value of the car. It was the one that's worth £4,000. Okay, so that one is £4,000. Use the graph to estimate the value of a new car of this make and model in 2019. Okay, so if it's new, then it is 0 years old then, isn't it? So I'm going to read up from 0 till I hit the curve, well, the line of best fit, and that would indicate what the new cost of the car is. Okay, so I can see that's like 3 little boxes up from 14,000. So I've got 5 little boxes that span £2,000. So each little box is going to be a fifth of £2,000. If you divide 2,000 by 5, you're going to get £400. So each one of those is worth 400. So I'm thinking that's 14,000, 14,400, 800, 15,200. So that is my estimate. I'm going to estimate that the new car is worth £15,200. Right, and this is a car of this make and model had a value of £5,600 in 2019. Use the graph to estimate the year in which it was made. So we need to look up at 5,600 then. So again, if each one of these little squares is 400, then I'm going to go one square down from 6,000, aren't I? So one little square down from 6,000 must be 5,600. So from that point, I'm going to read across to the curve, to the line of best fit, and then change direction and read down. So just zip along to the line, spin round, go down. So we estimate that it's just under 7 years old. Okay, so I'd use my graph to estimate that it's 7 years old. Okay, slightly lower than 7, but it's an estimate, so I'm just going to round it off to the nearest year. Okay, but the question does ask in which year was it made and not how old it is. So if it's 2019 now, and we're thinking it's a 7-year-old car, then year of manufacture then, or year of make, is going to be 2019 minus that 7 years then, isn't it? It's going to be 2012. Okay, so I think it must have been made in 2012 in order for it to be about that price now. Question 19, here are a triangle and a rectangle. A and B are positive numbers. Which shape has the larger perimeter? You must work out expressions for both perimeters. Okay, now the perimeter of a shape is, imagine you're like an ant, and you're standing here, and then you kind of go for a stroll along here, and then down here, and then back along here again. So you basically walk around the whole edge of the shape. That is the perimeter then. Okay, so my perimeter for this shape is going to be this side here, 5a plus b, 5a plus b, and then plus this side here, which is 4a plus 7b, plus 4a plus 7b, and then this side here then, isn't it, which is 2a plus 3b. Okay, and then that simplifies down to what like terms have we got? I've got 5a, 4a, 2a, 5a plus 4a plus 2a, that adds up to 11a, doesn't it? That's 11a. And I've got b, 7b, 3b, which adds up to 11b. Okay, so I've got 11a plus 11b for that one. Now for my rectangle, perimeter is equal to, again, if I start in one corner of the shape and walk around it, so first I'm going to walk up here. Now that's going to be the same as its side opposite, isn't it? Because a rectangle, they have equal length sides, so this is going to be a plus 4b as well. And while I'm at it, these two sides are equal, so that's 4a plus 2b as well, isn't it? So then the perimeter is going to be that a plus 4b that we just talked about, then plus the 4a plus 2b, and then we're going to plus the a plus 4b again, plus a plus 4b, and then finally the 4a plus 2b that takes me back to where I started from. So 4a plus 2b. Now again, I'm going to just go and collect like terms. So I've got an a 4a, an a, and a 4a. So an a and a 4a, an a and a 4a, that's 10a, isn't it? So that adds up to 10a. And then I've got a 4b, a 2b, a 4b, and a 2b. And that adds up to 12b. So what is bigger, 10a plus 12b or 11a plus 11b? Now I sat and stared at this for a minute or two thinking, what have I missed? But I don't think I have missed anything. I just think that you can't tell from what we got on the page. Now if you had like 10a plus 11b, then I could see that 10a plus 12b was bigger than 10a plus 11b. But here I don't know, because I've got one less a in this one, so I've got one less a, but I've got one more b. So it depends, doesn't it? If a is bigger than b, then the triangle is going to be bigger, but if b is bigger than a, then the rectangle is going to be bigger. So at the moment I can't tell. Okay, so impossible to tell which is biggest. Okay, so at the moment it's impossible to tell which is biggest from the information that we've been given. The thing I missed was the tick boxes further down. Silly me. Yeah, so it's that one there, cannot tell. Okay, so it's you can't tell because it could be either, depending on the relative size of a and b, which I don't know. Okay, can't tell. Question 20, the nth term of a sequence is 19 minus 4n. What's the smallest value of n that gives a negative term? Okay. Well, let's just generate. I think the quickest way is just to generate a number of terms. So when n is equal to something, what is 19 minus 4n equal to? So if n is 1, then 19 minus 4n is going to be 19 minus 4 lots of 1. That's going to be 15. When n is 2, then 19 minus 4n is going to be 19 minus 4 lots of 2. That's going to be 19 minus 8, which is 11. 3 is going to give me 4 less. That's going to be 7. 4 is going to be 4 less. That's going to be 3. And 5 is going to be 4 less. That is going to be minus 1. So that's my first value that gives a negative term. Now after that, every other value of n is going to give a negative term. But my smallest value of n that gives a negative term is 5. So the answer is n is equal to 5. Question 1. What is the name of the longest possible chord in a circle? It's an interesting question. Okay, so if I draw a circle and then think about chords that I can draw. Now if I draw a chord close to here, it's small. And if I move slightly, it gets longer. If I move slightly, it gets longer. If I move slightly, it gets longer. And so on. If I move slightly, it gets longer. But there comes a point where I get to the longest it can draw, which is here, isn't it? Because if I move further than that, it's going to get smaller again. So this one starts getting smaller, starts getting smaller, starts getting smaller, and so on. Okay? So hopefully you can see that you get the longest chord length when the chord lies kind of halfway through the circle. In other words, when it passes through the center of the circle. In other words, when it's a diameter. Okay, so the longest possible chord that you can draw is a diameter. Question 22. The number of people living in a town is 47,000 to the nearest 1,000. Which one of these is a possible number of people living in the town? Circle your answer. Okay, now this is a limits of accuracy or an error interval question, isn't it? So if I drew a number line and I marked on the number that they gave me, which was 47,000, So I've marked 47,000. So if this has been rounded off to the nearest thousand, then 1,000 above 47,000 is 48,000, and 1,000 below 47,000 is 46,000. So the numbers that round to 47,000 are the numbers that are halfway between 47,000 and 46,000, or halfway between 47,000 and 48,000, or nearer. So this is the kind of golden zone that rounds to 47,000. So halfway between 46 and 47,000 is 46,500, and halfway between 47,000 and 48,000 is 47,500. Okay, so 46,000, that is too low. 46,000 is here, so it's not that one. 46,500, ooh, that's right on the cusp. Let's come back to that one. 47,500, ooh, that's right on the cusp. Let's come back to that one. 48,000, that one is well out. Okay, so we're definitely going to rule out those two. Now, which one is in the zone? Now, if you think about the error interval, 46,500 rounds up to 47,000, so that is included in the error interval. Okay, but 47,500 technically rounds up to 48,000. So whilst it represents the boundary of where the error interval ends, actually this number would round up and not down. Okay, so that would round up to 48,000. So it's not that one, which means it is that one there. Question 7. Jeff and Kaz shared £270 in the ratio Jeff to Kaz of 2.6 to 1. How much more does Jeff get? Okay. So when we're dividing by a ratio, the first thing we need to know is the total number of shares, which we can get by taking the ratio and adding the two bits together. So 2.6 plus 1 means that if Jeff gets 2.6 shares for every Kaz is 1, then altogether there are 3.6 shares. Okay? So then we need to work out the number of shares there are in £270. So 270 divided by 3.6. What does that give me? So 270 divided by 3.6. That comes out to be 75 shares, or 75 rounds of dishing out money. So that means if we take the ratio of 2.6 to 1 and scale it up by a factor of 75, we should get the amount that the two receive. Okay, well, one on the right, Kaz's one's pretty easy. 1 times 75 is 75. But what's 75 times 2.6? That's 195. Okay. So that means Jeff gets £195 and Kaz gets 75. Okay, so the difference then is going to be 195 minus 75. What's that? That's is that 120? It's £120. Question 24. Here are two rectangles. Yes, there are. We need to show that the rectangles are similar. Now, if two rectangles are similar, it means that their sides are in the same ratio. And that means if I take this one and I divide it by this one, I should get the same answer as if I take this one and I divide it by this one. If I do, then they're in the same ratio. Otherwise, they're not. Okay? So what is 28 over 40? If I write that down as a fraction and then simplify it. So 28 over 40 as a fraction. That is the same thing as 7/10. What is 35 over 50 in its lowest terms? 35 over 50. Oh, look at that. That's also 7/10. Okay, so I can say both rectangles have their sides in the same ratio, therefore they are similar. Okay, now you can also do it by finding the scale factor of here and showing it's the same as that. That's also another way of doing it. But, you know, they're both telling you pretty much the same thing. It just tells you that the sides are in the same ratio. Okay, so either of those approaches are perfectly valid. Either showing that two sides in the same rectangle are in the same ratio as the other one, or matching pairs on the two rectangles are in the same ratio, or in other words, have the same scale factor. Okay, good. Let's move on. Question 25. The equation of a straight line is 2y equals 6x plus 8. Okay. Now, and we're asked to circle the gradient of the line. Well, the gradient of a line, the gradient of a straight line in the form y equals mx plus c is m, isn't it? It's that value in front of the x term. That is the gradient. Okay. So here you might be thinking that 6 there might be the gradient because that's the coefficient of x in the value we've been given. But if you look here, this says 2y and not y, so that's a problem. Okay, in order to read out the gradient, we need to change this so it says y is equal to and not 2y is equal to. So what we're going to do is going to take the equation 2y is equal to 6x plus 8, and we're going to divide everything by 2. So 2y divided by 2, divide by 2, divide by 2. That's going to cancel, leaving you with y on the left. And then dividing 6x by 2, that's 3x. Dividing 8 by 2, that's 4. So this resolves to y is equal to 3x plus 4. And so then my m value then is that 3. It's that coefficient of x there. Okay, so that means that the gradient of this line is 3 and not 6. Don't fall into that trap. It's got to be in the form y is equal to mx plus c in order for you to read out the gradient. At a country park, there is a house, a museum, and a garden. The table shows the price per person to visit the park. So the garden only is free. The house and the museum is £12.50. The house only is £8 and the museum only is £7. One day, 480 people visit the park. 67 visit the gardens only. 40% visit the house and the museum. 3/8 visit the house only. The rest visit the museum only. In total, how much do the 480 people pay to visit the park? You may use the Venn diagram to help you. Okay, so we've got a little Venn diagram over here. Let's go through this line by line and see what we can do. One day, 480 people visit the park. We'll come back to that. We can't use it just yet. 67 people visit the garden only. That we can use. So if we've got house, museum, that's actually already on there. Look, it's there, 67. Okay, right. So 40% visit the house and the museum. What's 40% of 480? Final, original, multiplier. Final is what we want. Original is what we started with. 480 multiplier is 40%, which as a decimal is 0.4. Okay, so the final is what we want. So cover that up. So final equals original times multiplier. Okay, so then that is equal to 480 multiplied by 0.4. What's 480 times 0.4? My 8 looks weird. Let me just write that again. 480 times 0.4. 480 times 0.4. That comes out to be 192. Okay, so remember that was the people that were house and museum. And on the Venn diagram then, they're the people who belong in the middle then, aren't they? So that's 192 in there. Okay? And then we've got 3/8 visit the house only. What's 3/8 of the total then? So house only, that's going to be 3/8 of 480 then, isn't it? What's that? 3/8 of 480. That's 180. So that's house only. 180. Okay, so we dealt with that one. And finally, we've got the rest of the visit, the museum only. And we can work that out from the first fact that we had there. Forgot to write down 180 there. Yeah, we had 480 people to start with, and we know what all the other areas of my Venn diagram are. So museum only to be the rest of the 480 then, isn't it? So what we're going to do is going to take those three numbers away from 480. It's going to be 480, which is everyone, minus the other three areas, so 67, 180, and 192. What's that come to? So 480 minus 67 plus 180 plus 192. Doesn't leave that many, does it? It means it leaves 41. 41 are museum only, so that goes in there. Okay, so then what is the total that they pay then to visit the park? So garden only is free. House only is £8, so we're going to be multiplying that amount by 8. House and museum is £12.50, and museum only is £7. Okay, so we're going to do those and add them up, aren't we? So then the total cost, let's get a bit more space. So then the total payments, that's going to be 180 times 8 plus 192 times £12.50 plus 41 lots of £7. What's that equal to then? Okay, job for the calculator. 180 times 8 plus 192 times £12.50 plus 41 times 7. I make that £4,127. Okay, not bad for a day's work. The heel of a shoe exerts a pressure of 198 pounds per square inch. Convert this pressure into kilograms per square centimetre. Use 1 pound equals 0.45 kilograms and 1 square inch equals 6.25 square centimetres. Okay, now what's missing here is it's the formula for pressure. Do you know what it is? Pressure is equal to mass divided by area. Okay, so pressure is equal to mass divided by area. So the greater the mass, the smaller the area, the higher the pressure. Okay, so convert pressure in kilograms per square centimetre. So we know that it's 198 pounds per square inch, and we want to know what that is in kilograms first. So let's convert it into kilograms first. We're going to use the 1 pound equals 0.45 kilograms first. So we're going to multiply then that 198 by 0.45. Okay, because mass is on the toplet. So we're going to multiply the top part here by 0.45 to convert pounds into kilograms. So 198 times 0.45 comes to 89.1. That's going to be kilograms per square inch. Okay, and then to go from inches into square centimetre, 1 square inch equals 6.25 square centimetres. Now to convert then inches to square centimetres, we need to multiply the area by 6.25, but area is on the bottom, so actually another way of thinking about it is dividing by that then to convert it. So that's going to be equal to 89.1 divided by 6.25 then. What's that? Divide by 6.25. That comes out to be 14.256. And that's going to be kg per square centimetre. Okay, so that's the answer we're looking for, 14.256. 6 positive numbers have a mean of 10, a range of 19. 4 of the numbers are 12, 7, 15 and 3. Work out the other 2 numbers. Right, I'm going to start with looking at the mean of 10, because I know if I can work out a mean by dividing the total of all the numbers divided by the number of numbers. Okay, now I know that the number of numbers is 6. The total of numbers I don't know, but I know the mean is 10. Okay, so I can work out the total of numbers then by multiplying through by 6. And if I multiply both sides by 6, look, I'm going to get 60 is equal to the total of all the numbers, because they're going to cancel. Leave you with a total of numbers on the right. Okay, so that means my numbers add up to 60. At the moment, I've got 12 plus 7 plus 15 plus 3. That adds up to what? 12 and 7 is 19, and 15 is 29, 34, and 3 is 37. So they add up to 37, which means that the 2 missing numbers are going to be the total minus the total of the 4 that we know. So that leaves 23. Now at the moment I've got, I'm just going to rewrite these in order. So I've got 3, 7, 12 and 15. Now I've got 2 extra numbers to add. Now the range is 19, so either the highest number then is going to be 19 more than the lowest number. So that could mean I've got like a 22 as my highest number, or I suppose it could mean that 15 was my highest number and my lowest number is going to be 19 less, which would be -4. So is it going to be -4, or is it going to be 22? Well, it can't be -4, because if they add up to 23, then that means the other number must be 27. So 27 and -4 make 23. So that one's out. Can't be -4. So it could be 22, couldn't it? So if it was 22, though, I've got a problem, because I've got 1 left over. And that means I'd have a 1 here. And now the range isn't 19 anymore. Now the range is 21. This is a slight problem. What about then if it is 1 less than 22? Let's change it then. Let's say, well, it's not 22 then. Let's try 21. So if it was 21 instead, then the lowest number would be 19 less than 21. It would be 2. Does that work? So I've got 2 and 21. That makes 23. And the range between them is 19. So that does seem to work. Okay, so 2, 3, 7, 12, 15 and 21. So the 2 numbers are 2 and 21. A solid shape is drawn on isometric paper. There it is. And part A says, on the centimetre grid, draw the elevation of the shape from A. Okay, well, if you're standing at the point A, what are you going to see? If I'm standing over here. Right, I'm going to see this face, aren't I? Right in front of me. And that face is a 2 by 2 rectangle. Okay, so I'm going to see that on my grid. So I'm going to draw a 2 by 2 rectangle to start with. So then that's the yellow bit, isn't it? Let me just shade that in as well so you can see it. Okay, but that's not all I can see. I can also see this from my vantage point. Okay, it's going to be a little bit further off, but I should still be able to see it. I'm not going to be able to see this side, That one I won't be able to see, or the top, or that side, but I'll be able to see that green bit. Okay, so I'm going to add that on as well. Now that is a rectangle which is a width 1 and a height of 2, isn't it? Okay, so I'm going to see a little bit extra on the side of this shape. Okay, it's not necessarily for you to shade it. I'm just shading it so you can see what I'm talking about really a little bit more clearly. Okay, you just need to draw the lines. But I've shaded in so I can refer to the various faces that you can see, that I can see, and so you get that idea from me. Okay, so that's the front elevation. Okay, now part B says draw a plan of the shape. Now you can think about the plan in two ways. You can either think of it as a bird's eye view looking down from the top. Okay, so that's the plan view from here. Or the other way of thinking about it is it's the footprint of the shape. So if you imagine that was like a cookie cutter, what shape would it cut out if you kind of punched it into the ground? Okay, that's what we need to draw. So I'm going to do it from the same perspective, so that A being at the bottom, and then I'm going to draw like the plan from what I can see. Now, if you look at the distance from there to there, how far is that? That's 1, 2, 3, 4, 5 squares. That's 2. That's 2. That's 1. That's 3, and that's 3. So that's what I need to draw. So I'm going to draw the 5 first. So I'm just going to shade that one as well so it's clear what I'm talking about. So that is the face that I'm seeing from above. But again, you don't need to shade it. I'm just really giving you an idea of what I can see a little bit more clearly. Eric thinks of a prime number between 20 and 30. His number is x% of 125. Work out one possible value of x. Okay. So, right, what could the number be first? Prime numbers between 20 and 30. What are the choices here? Primes between 20 and 30. What are they then? 21, no, because that's 3 times 7. 23. 25, no. 27, no. 29. So there's only two, 23 and 29, aren't they? They're the two possibilities. Okay, his number is x% of 125. Okay, so x% of 125. Well, when you're finding x%, you are finding x 100ths of your amount, aren't you? So if x% of 125 is his number, then x over 100 times 125 is either 23 or it's 29. I'm going to go for 23 for now because I don't know. It's just the first one in the list, and I just need to pick one possible one. So I don't need to do both, just need to pick one and use it. Okay, so let's try and isolate x. Let's multiply both sides by 100 to start with. That leaves me with x times 125, or 125x, is equal to 2300 then. Okay, then so x is going to be 2300 divided by 125 then, isn't it? If I divide both sides by 125, that's going to cancel. And what is 2300 divided by 125? 2300 divided by 125. That's 18.4. So x is 18.4. It's not 18.4%, it's just 18.4, because x% is what we're using. So we're using x must be 18.4 by itself. Okay, good. Now I could work out for 29 as well, but it only wants one. I found one. I'm done. No point in wasting time. Let's move on. Part of a regular polygon with 15 sides is shown. Work out the size of an interior angle. Okay, now this is a regular polygon, so each interior angle, there's a formula for it, isn't it? It's you take the number of sides n, you subtract 2, and so that tells you the number of triangles inside your shape, times it by 180 will give you the total of all of the interior angles, and then divide it by n will tell you what one regular interior angle would be. Okay, so that's the formula for interior angles of a regular polygon. So for a 15-sided polygon, n is 15, so we're going to get 15 minus 2 times 180 over 15, or in other words 13 times 180 over 15. What's that then? 13 times 180 divided by 15, that comes out to be 156 degrees. Doesn't it look about right? Well, it's almost a straight line, this one, isn't it? So it should be getting that way. Yeah, 156 degrees. Now, if you find that rule hard to remember, you can also just use the fact that interior and exterior angles sum to 180 degrees, because exterior angles are a lot easier to find. So if I extend that line outlet, then the exterior angle is this one here, and this one is just 360 degrees divided by n. So what you can do is do that first and then use that one, and the fact that angles on a straight line add up to 180 to give you your interior angle. Okay, so that also works. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.